Okay, so now we're on to page 2. On the back, on this video, we're going to do problems 15 and 16. Here we see our regular guy, Slim Jim. He's in his galactic cruiser. It's stationary when he shoots his space cannon. And this is the little cannonball, and it's going to be moving at 800 meters per second. It has a mass of 1.5 kilograms. And at first, what we're supposed to do is just fill in some basic information. What is the mass of the ship? Oh man, this is really hard. This is an honors class for sure. 2,500 kilograms. What is the weight of the ship? Well, the weight of the ship is 0 newtons because it's in space. Okay, calculate the final velocity of the ship. Well, what we need to remember here is that momentum must be conserved. So we're going to start with our conservation of momentum equation. So here we have 0 is going to equal the momentum of object 1 after plus the momentum of object 2 after. Object 1 here would be the galactic cruiser, and object 2 would be the cannonball. So with that as our equation, what we can say then is that 2,500 of some velocity plus 1.5 times 800 would equal 0. And so once we move some stuff around, we can say negative 1,200 is going to be equal to 2,500 V. And once we do all the math, we can see that V is equal to negative 0.48 meters per second. Oops. And then for the one down here, which has more momentum afterwards? Is it the ship or the projectile? They are the same, however, one is going to be negative. Okay, so that was kind of easy. Let's scroll down and take a look at problem 16. Alright, so here we have problem number 16. It says a 20-gram bullet is shot 800 meters per second to a 50-kilogram object that is at rest. So here we have our object at rest, and what we need to do is we need to find the mass of the combined... First we need to change the mass of the bullet to grams. So it's 20 grams, we need to change it to kilograms. So that is simply... I don't know why this is happening. This is simply going to be 0.02 kilograms. So that's there. B, what is the mass of the combined object? Well, when they combine, we're going to have the bullet, 0.2, in this 50 gram, or 50 kilogram thing, so it's going to be 50.02 kilograms. What is the initial momentum of the bullet? Well, the initial momentum would be 0.02 times 800, which is going to equal to 16 kilogram meters per second. And how much momentum does the combined object have afterwards? Well, momentum has to be conserved, so it's going to be the same. Has to. Okay, under the diagram, find the final speed of the combined object. So here we're trying to solve for V. Okay, we know that the momentum, the final momentum, is 16 kilogram meters per second. So there we just need to solve for velocity. And once we do that, then we'll find that velocity is equal to 0.32 meters per second, so it slowed down quite a bit. What kind of collision is this? This is a perfectly inelastic collision because we have things getting stuck together, and that only happens in perfectly inelastic collisions. Okay, so lastly, the numbers are realistic for a bullet and a person. In movies, a bullet causes a person to be thrown backwards violently. How likely is the movie scenario? And to explain. Well, remember that the final momentum here equals the momentum of the bullet. And it just so happens that the momentum of the bullet is equal but opposite in direction to the momentum given to the shooter who shot the bullet. Okay, so follow my logic here. So, in order for a bullet to violently throw someone backwards, meant that whenever that same gun was fired, the person who shot it had to be violently thrown backwards as well, because the conservation of momentum had to be conserved. So it's not very likely. I'm not going to write all that out, but that's basically the answer, and hopefully if you can picture that, it'll make sense to you.